Right now, a human-made object is flying closer to the sun than anything in history. Not skimming past it, not orbiting at a distance. It's diving into the sun's atmosphere, enduring temperatures that can melt metal and radiation strong enough to destroy most spacecraft instantly. And somehow, it's still alive. In 2018, NASA launched a mission that pushed engineering to its absolute limits. The spacecraft was called the Parker Solar Probe. Its objectives sounded simple, but it had never been done before. Touch the sun. For decades, scientists could only observe the sun from a safe distance. Telescopes, satellites, simulations, all of them limited by one thing: distance. To truly understand the sun, we had to go there. The sun might look calm from Earth, a steady, glowing sphere in the sky, but up close, it's violent beyond imagination. The surface constantly erupts with explosions called solar flares, releasing energy equivalent to millions of nuclear bombs. Streams of charged particles, known as the solar wind, blast outward at incredible speeds. And then there's the corona, the sun's outer atmosphere, a place where temperatures reach millions of degrees, far hotter than the surface below it. Which makes no sense. By the laws of physics, the farther you move from a heat source, the cooler it should get. But the sun breaks that rule, and no one knew why. To survive this journey, engineers had to solve a nearly impossible problem. How do you build something that won't melt when flying into a star? The answer was a revolutionary heat shield. A thick carbon composite barrier designed to absorb extreme heat while reflecting most of it away. On the side facing the sun, temperatures can reach around 2,500 degrees Fahrenheit, hot enough to melt steel. But just inches behind that shield, the spacecraft remains close to room temperature. Everything depends on that shield. If it fails for even a moment, the mission is over. Getting close to the sun isn't just about pointing a rocket and going straight in. Earth is moving around the sun at incredible speed. To fall inward, the probe had to cancel that motion. So instead of heading directly toward the sun, the Parker Solar Probe used a series of gravitational slingshots around Venus. Each pass around Venus steals a bit of orbital energy, pulling the spacecraft closer and closer to the sun. With every orbit, it dives deeper, moves faster, gets hotter. As it falls closer, something extraordinary happens. The probe accelerates, faster and faster, until it becomes the fastest human-made object ever built, reaching speeds of over 430,000 miles per hour. At that velocity, you could travel across the entire United States in under half a minute. Nothing in history has ever moved this fast. And it needs that speed, because staying near the sun too long would destroy it. Then came the moment no spacecraft had ever achieved. The Parker Solar Probe crossed a boundary known as the Alphen Critical Surface, the point where the sun's magnetic field loses control over the solar wind. Beyond this boundary, you are no longer just near the sun. You are inside it, inside the corona, inside a storm of superheated plasma, twisting magnetic fields, and violent streams of charged particles. Humanity had officially touched the sun. And what it discovered was unexpected. The solar wind wasn't smooth and steady like scientists predicted. Instead, it was chaotic, filled with sudden sharp reversals in direction, called switchbacks. Imagine a river flowing outward from the sun, but constantly snapping back on itself in violent bursts. These switchbacks revealed that the sun's magnetic field is far more dynamic and unstable than we ever realized. They may even explain how energy travels from the sun into the rest of the solar system. But one mystery still remains. Why is the corona hotter than the surface? The probe's data suggests that tiny, explosive bursts of energy, possibly billions of them happening constantly, may be heating the corona from within. If confirmed, this would solve a mystery that has puzzled scientists for decades. This isn't just about understanding the sun, it's about protecting Earth. The same forces the probe is studying can unleash powerful solar storms. These storms can disable satellites, disrupt GPS systems, expose astronauts to dangerous radiation, and even shut down entire power grids. In 1989, a solar storm knocked out electricity across Quebec. If a stronger one hits today, the consequences could be far worse. Understanding the sun isn't optional anymore. It's necessary. The Parker Solar Probe is still out there, still orbiting, still diving closer, still pushing deeper into a place no machine was ever meant to go. Each pass brings it closer to the sun than the last, closer to answers, closer to danger. We built a machine to touch a star. And somehow, it survived. But the real question is, what happens when it goes even deeper?